Hello, this is our presentation for Project 4 for ME3210. Here's the agenda for today. Hi, I'm Leo Lam and I'll be talking about augmented reality. Augmented reality, or AR, takes what the user sees in real life and overlays a computer-generated virtual scene that provides the user with additional information. It usually consists of a virtualization device, capture device, interaction device, and tracking system. Applications for AR are prevalent in the medical industry, interior design and modeling, education, and manufacturing. AR is very important because of how effective it makes the assembly and disassembly process. It creates an immersive experience by providing information to guide the user throughout the entire process. The same thing for maintenance, it helps the technician avoid mistakes and save time by assisting them in real time. The reason why I like AR is because of how versatile it is. At its most basic level, it does not require much physically, but it can provide so much information. AR helps design better products by giving a real scale perspective on products. For example, I designed a locking mechanism at my internship, but once I printed it, I realized it was way too small to work. AR would have prevented this mistake, saving resources and time. AR increases efficiency in manufacturing by reducing mistakes in maintenance. It also helps speed up the learning curve for any disassembly or assembly work. In summary, AR lets you see and manipulate 3D objects in the space/world, which brings the virtual world into the real world. It minimizes errors and mistakes in maintenance. Limitations, however, include requiring a device to capture and display information. Finally, the technology is not fully fleshed out, so rapid movement can disrupt the scene.
Hi, my name is Vishnupriya, and I will be presenting lean manufacturing and lean production. This methodology is focused on minimizing waste while improving productivity and product quality. The goal is to eliminate non-value adding activities or waste, such as overproduction, unnecessary motion, waiting times, and deflections, all without compromising the value delivered to customers. Lean manufacturing has been widely applied in industries like automotive manufacturing. For example, Toyota pioneered the just-in-time system, which ensures that parts are delivered exactly when needed. Reducing inventory costs and improving efficiency, Dell has applied lean in their supply chain to reduce excess inventory and deliver custom-built computers quickly. So why is lean manufacturing so important? It reduces operational costs and improves product quality by focusing on efficiency. It also helps companies become more agile, which is critical in today's fast-paced business environment. In terms of designing and manufacturing better products, lean ensures a more streamlined production process. It reduces lead times, ensures high-quality products, and helps get products to market faster. However, there are some challenges. Implementing lean in large and complex production systems can be difficult, and it requires a commitment to continuous improvement from everyone involved. The Kano model. This model was developed by Professor Noriaki Kano in the 1980s. The model breaks down customer expectations into 5 categories: basic needs, performance needs, excitement needs, indifferent needs, and reverse needs. The Kano model is incredibly valuable because it helps companies focus on what really matters to customers. For instance, Apple uses the Kano model to prioritize performance and excitement needs. The multi-touch interface on the original iPhone was an unexpected feature that blew customers away, giving Apple a competitive edge. In terms of product design and manufacturing, the Kano model ensures that features are prioritized according to their impact on customer satisfaction. This leads to products that not only meet customer expectations, but also exceeds them. However, a challenge with the Kano model is that identifying excitement needs can be subjective and often requires continuous customer feedback.
Minimum viable product. A minimum viable product, also known as MVP, is the simplest version of a product that needs to be built before it can be sold. An MVP aims to give as much information about what a consumer thinks about a product while investing as little resources as possible. An MVP focuses on the functionality of a product. MVPs are typically used in software. For example, Uber started off as an MVP being an iPhone SMS service with taxis. Dropbox also used to be an MVP. A physical example is using a milk carton and a straw to funnel milk directly into a coffee machine to make drinks like lattes. MVPs are important because they allow you to make any adjustments to your product based on market feedback before investing large sums of money. I like MVPs because it enables rapid testing and refinement of your idea or product. They're essentially proof of concepts and encourage the pursuit of new ideas as they enable you to test these new ideas without that many resources. MVPs are utilized to design better products since they help scout the audience to gauge their interest. Feedback leads to removing or abandoning any undesired features or ideas, as well as adding desired features or ideas. In summary, MVPs are able to gauge a customer's interest. It's able to provide a proof of concept while using as little resources as possible. However, MVPs only test functionality, so a customer's preference to any appearance or other factors are indeterminate.
Collaborative robots, or cobots, are robots specifically designed to collaborate with humans. Like all robots, they are used to speed up production processes and increase output while maintaining product quality. These robots perform the repetitive tasks that often cause repetitive strain injuries to production workers. What makes cobots special are their sensors that detect their proximity to human workers. Cobots will avoid getting too close to humans, and if a collision does occur, they can shut down into safety mode, whereas traditional robots would continue operating, potentially injuring someone. Cobots with specially designed sensors can perform quality control inspections. They are also able to weld, solder, and screw, as well as apply adhesives and sealant. Using their pick-and-place capabilities, they are able to perform the task of palletizing, depalletizing, and machine sending, which is the loading and unloading of production machines. Cobots can follow any contour while applying a constant force to the surface, which makes them perfect for sanding, polishing, and deburring surfaces. Like all robots, they are used for performing repetitive, monotonous, and potentially dangerous tasks. This allows human workers to apply their skills in more creative endeavors. However, the advantage of cobots over traditional industrial robots is that they are specifically designed to safely operate in the same workspace as people without the need for safety fencing. This means they are intended to complement human labor by working alongside people rather than entirely replacing people. The lack of need for safety fencing means that, unlike most industrial robots, they are not localized to one spot. This, along with their lightweight and mobility, means they can be easily transported and redeployed to different areas of a warehouse, making them adaptable and capable of performing many different tasks. This makes them suitable for high-mix, low-volume production, which is becoming increasingly common with consumers' desire for specialized customization. Cobots are capable of completing a variety of tasks while safely working in close proximity to human workers. They are also much easier than traditional industrial robots. Program and operate. However, cobots are not without their drawbacks. To safely operate near humans, they are designed to only carry lightweight payloads at slow speeds. Cobots are also a relatively new technology, which means they are still expensive.
Let's talk about digital twins. A digital twin is a virtual replica of a physical object, system, or process. It is used to simulate, predict, and analyze real-world performance, allowing businesses to optimize processes and products in real time. In the manufacturing sector, companies like Siemens and General Electric use digital twins extensively. Siemens uses them to simulate entire factory operations, testing processes before they are implemented in the real world, which minimizes downtime and improves efficiency. BMW uses digital twins to monitor the life cycle of cars from production to end of life, ensuring quality control throughout. The power of digital twins lies in their ability to provide real-time insights. They use data from sensors on the physical object to update the virtual model continuously. This enables predictive maintenance and process optimization. This means manufacturers can detect potential issues before they occur, saving both time and money. This reduces the likelihood of costly mistakes and accelerates the design cycle. However, creating and maintaining digital twins can be expensive, and they require continuous data input to remain effective.
Value stream mapping. Value stream mapping is essentially a flowchart that documents every step in the process. It's a tool that's inspired by lean manufacturing. It helps identify waste, reduce process cycle time, and implement process improvement. This image shows a digital example of a value stream map. Applications include combining material process steps with information flow. Toyota used value stream mapping to visualize their entire process to make sure each step in the process only does what was needed. Another example is a rope manufacturing company, which saved 33% on their material handling time utilizing value stream mapping. Value stream mapping is important because it maximizes the available resources. It helps facilitate clear communication and cooperation between teams. I like how it emphasizes cross-functional work because during my internship, my work required lots of cross-functional work, and I learned of the importance of cross-functional communication. Value stream mapping helps manufacture better products since it analyzes areas of improvement in the flow between processes. In design, it helps improve communication and cooperation, which ensures every team is on the same page, which increases efficiency. Value stream mapping doesn't have to be super neat and digital like the first figure I showed. Using sticky notes is an effective and fast way to visualize the process. In summary, value stream mapping is able to visualize systems to identify areas of improvement. Furthermore, it optimizes processes and improves cross-functional work. Limitations include the fact that value stream mapping is a tool purely for identification. It does not facilitate how exactly to improve that area of weakness.
The Industrial Internet of Things, or IIoT, is a system of devices all connected via a network that collect, exchange, and analyze data. These devices work together and make real-time decisions based on this data with the goal of increasing the efficiency and reliability of production processes. IIoT systems can efficiently track assets throughout the supply chain. Smart meters are sensors that collect and transmit real-time energy consumption data to utility companies and can be programmed to optimize the use of energy during periods of low demand. Another application in the energy industry is IIoT sensors that can detect oil or gas pipeline leaks and alert maintenance teams. This helps prevent potentially dangerous situations, loss of product, and it also ensures a steady supply of product to customers at all times. Using IIoT systems, companies are able to save time and money by detecting and eliminating inefficiencies and problems in production processes. IIoT uses its real-time data generation to instantly correct faults in the production process. The use of RFID tags or QR codes on every part means that the root cause of any defective part is able to be traced. And also detect part defects in real time. So instead of producing an entire batch of defective parts before the defects are detected, only one part is produced incorrectly before the IIoT system corrects its production of further parts. IIoT systems can predict when a machine will need maintenance so that it can be serviced before failure. IIoT systems are useful for automatic quality control inspections as well as supply chain traceability efficiency. However, IIoT systems are costly, complex, vulnerable to hackers, and they require technological expertise that few workers have. Generative design is the design process that uses AI to generate a variety of design alternatives based on user-inputted parameters such as materials, manufacturing methods, and performance requirements. Generative design considers multiple alternatives and makes them converge on a solution based on these parameters. Generative design can be used to create customized medical implants and prosthetics tailored to individual anatomies. It can also be used to create designs for aircraft parts that are lightweight yet structurally sound and aerodynamic. It can create aircraft designs that maximize fuselage space while minimizing the aircraft weight. Generative design allows for the creation of complex, optimized parts that use less material and are quicker to produce. These designs are original, innovative designs that humans may not have considered. These designs minimize material waste and reduce the carbon footprint of the production process. Generative design typically generates parts with complex organic geometry that can only be feasibly produced by additive manufacturing, like 3D printing, which is good for high-mix, low-volume production. 3D printing allows the mass customization that generative design facilitates. Designs produced by generative design often consolidate multiple parts into a single part, which reduces assembly cost and streamlines the supply chain. Generative design reduces the trial and error work, which is normally required by traditional designs. It shortens research and development times for new products. It also allows for the simultaneous creation, exploration, and comparison of numerous different design options. However, many of the designs created by generative design are only able to be produced with additive manufacturing due to their complex and often organic geometry. Oftentimes, the reasoning behind certain generative designs produced by AI may be unclear.
Light-out factory. A light-out factory at its truest and most extreme definition is a fully automated factory. That means humans never touch the product during the process and it would operate 24/7, excluding times for maintenance. A light-out factory is geared towards simple, repetitive tasks and is often utilizing AI, machine learning, robots, and/or sensors. Applications include in the process industry because they typically deal with products where human contact can damage or contaminate the product, like food or microchip industries. It's also been used to automate making automobile frames and also for assembly plants. Light-out factories are important because it reduces the amount of accidents, increasing safety. It also creates consistent quality because robots can be very consistent. I like it because although it seems slightly futuristic, we're much closer than we realize. For example, Fanuc is a Japanese manufacturing company that has been running lights out for 25 days at a time since 2001, which is impressive and suggests that fully or near lights out factory is a plausible conclusion one day. Lights out factories manufacture better products since it manufactures faster and more consistently than other factories. Furthermore, it requires less resources once it's set up, as there are minimal human interactions, which means there are no or less labor cost. In conclusion, capabilities of light-out factories include increased consistency and efficiency, and being able to operate smoothly without constant human supervision and interaction. However, limitations include the fact that light-out factories are expensive to set up. Furthermore, it is difficult to create a light-out factories for more complex processes, and light-out factories inherently have an inability to react promptly to any emergencies. Here are our references for this project. As a disclaimer, this project was made for educational purposes.